The Rhode Island Coastal Hazards Analysis, Modeling and Prediction System, or RICHAMP, is a high-resolution hazard consequence modeling system designed to help state and local emergency managers and facility operators anticipate the consequences of a major storm striking their community. The ArcGIS-based platform serves as a real-time hazard and impact prediction system for hurricanes and nor'easters in southern New England, including cascading consequences of extreme weather impacting critical infrastructure, such as wastewater treatment facilities, sewer systems, airports, and seaports. The combined storm hazard and impact modeling system can predict not only when, for example, a critical backup generator may be flooded, but also the consequences of resulting loss of power for dependent infrastructure. The foundation of RICHAMP is a secure Arc Enterprise database of site-specific georeferenced consequence threshold data for critical infrastructure facilities and assets. This is IACT, the Infrastructure Asset Consequence Threshold Database. IACT georeferenced site information is collected directly from infrastructure managers using a mobile app, ensuring subsequent model outputs are relevant to facility operators' own emergency planning and decision-making. As the native database format for ArcGIS, Arc Enterprise combines geolocation data with traditional relational data into a powerful, scalable, and flexible platform that can, in the future, integrate additional spatially oriented datasets. Arc Enterprise's robust security features facilitate tiered access to IACT data based on defined user roles and permissions. This ensures sensitive facility and asset data is only visible to those with a need to know. For example, a facility operator is able to see information about their own facility, but not other facilities in their sector. Though it can utilize a number of different storm data sources, RICHAMP is primarily intended for use with advanced coastal storm surge, wave, and hydrological prediction models such as AdCirc. These high-resolution storm models are overlaid with ground-truthed, locally derived vulnerability data from the IACT Critical Infrastructure Database. RICHAMP then evaluates each entry's LiDAR elevation consequence threshold point against AdCirc storm model nodes to determine if the potential consequence will be triggered and, in most cases, the estimated time of occurrence and the duration of impact. And while RICHAMP provides real-time storm consequence predictions, it can also apply hypothetical simulated storm models for advanced planning and exercise purposes. This offers emergency planners and facility operators the ability to explore the distinct impacts of different storm scenarios rather than relying on the simple bathtub approach used by older simulation methods. The resulting output from RICHAMP simulations is visually displayed in an emergency operations center using the web-based ArcGIS dashboard viewer that combines IACT critical infrastructure data with wind, wave, and surge data from the storm models. The familiar ArcGIS interface reduces the learning curve for EOC personnel and offers the opportunity to integrate other existing datasets available to ArcGIS users, such as local roads, hospitals, and evacuation routes. RICHAMP's storm consequence predictions are organized as a time series, allowing EOC users to scroll through an hourly timeline and anticipate when specific impacts will need to be addressed. Predictions are automatically revised each time RICHAMP processes an updated storm forecast. Data displayed on the RICHAMP dashboard is automatically filtered based on a user's system roles and permissions. Entries can also be filtered based on critical infrastructure sector and other criteria. In addition to the interactive ArcGIS dashboard, RICHAMP can produce templated, time-stamped prediction reports in PDF form, summarizing anticipated consequences of the current storm scenario by facility, critical infrastructure sector, or emergency support function. These reports can be used for record-keeping in the EOC and can be shared with facility operators and local emergency management partners. Once fully operational, the RICHAMP system has the potential to transform the very nature of emergency management relating to storm surge, wind, and other coastal inundation events. This project has introduced capabilities that have long been sought but have never been feasible due to limitations in storm modeling and GIS data systems. When completed for Rhode Island, this approach can be adapted for other regions and applications.